area moment of inertia, centroid problems. It's probably going to read like this. The only thing possibly I can add to this is, hey, find me the radius of gyration. It's the only thing that's not on this. And sometimes I do put it on, sometimes I don't. Just depends on my mood. But you should be able to find the radius of gyration. Once you know I, it's the square root of I over A. It's a simple, straightforward calculation, so it's not like there's anything fancy going on.
What page is this?
It's not a page, this is an old test question. Or I got 3 questions, old test question. I told you I was going to do this today, bring in another old test question for you to check out. Right? You with me? Are you with me? You getting all this? You're getting it. Is she getting it?
Oh, yeah.
She got it. What's your major? Huh? World languages. And you're getting all this. Is this the girlfriend?
Yeah.
He does not love you.
Damn.
Because if he loved you, he wouldn't punish you by making you sit through this shit.
She wanted to experience you.
She wanted to experience me.
Yeah, because I talk about you to her all the time. She hears about you all the time.
So I'm dinner table chat. Extremely. You talk about me while you're here. So, what kind of world languages are you doing? French and Spanish. And why did you pick those two? They're what? You're passionate about, you should have probably picked Chinese. It is harder, but you know, the way they're going, they're trying to dominate the world. So you might have to speak Chinese. I don't know. Alright, so like I told you, it would probably be 3 or 4 pieces. I went ahead and divided this up into
We can't see again.
one big rectangle, one.
Nora, you can't see.
What? What happened? Why is this doing this? What the? Why is it doing this? I don't get it. Anyway, so I'm doing. Light doesn't work. No light for this. Zoom in and zoom out. Leave it like that. Okay. So you will have this attached to your test. So the test should have 5 pages, 3 test questions, and then 2 pages, one being this, and then the other being the table. So let me grab a table. Here's the table. So this is what I'm doing. I'm choosing a big rectangle, in which case I'm subtracting out 2 pieces, quarter circle and a triangle. So this looks like I have rectangle 1, quarter circle 2, and a triangle 3. All of these are cut out, so I'm going to put a minus sign immediately on them. So for the big rectangle, you can see that it's 9 by 6. So area 1 is base times height, 9 times 6, 54. So that's going in here. All right, quarter circle. is going to be area 2, which is pi r squared over 4. Remember, I use 3.142, please, times 3 quantity squared divided by 4. That's going to give me a minus 7.068. And I try to keep 3 decimals. And then area 3, 1/2 base times height, that's 1/2. Base is this base right here, height is 6. So this is 4.5 times 6. That's going to be minus 13.5. Sum this column gives me this 33.432. Now, I don't care how you slice it, dice it, mince it, mash it, whatever, it doesn't matter. You should have an area that is 33.432. I don't care how you subdivide it, the area is the area, that cannot change. So whatever you do, it's got to come out to this or something's wrong. Okay. So I now know x bar is some number divided by 33.432. Y bar is some number of 33.432 divided into a value. We're going to get that value. X bar, we're going from the y-axis to the center of that. That's going to be 4.5. We're going to go from the y-axis to the centroid of the quarter circle. That distance is 4r over 3 pi. That's going to be 4 times 3 divided by 3 pi. That's going to give me 1.273. And then from the y-axis over to the centroid, remember, this is 2/3 of the base, that's 1/3 of the base. So it's going to be 2/3 of the base, which is 4.5, plus you're going to add this distance in. That's going to be a total of 7.5. Multiply these two columns together, 243. Multiply these two columns together, minus 8.998. Multiply these two columns together, 101.25. Sum it. That's going to be 132.752. So this is 132.752. That's going to equal to 3.971. There's my X bar. Now that ain't that hard. Come on. I told you, if you can add, subtract, multiply, and divide, your test 3 should be a cupcake. If you don't get 100, I guarantee you, A, you didn't study enough, or B, you made a mathematical error. Forgot a negative sign, multiplied 2 wrong columns together, something that was silly. Why is it silly? Because you didn't pay attention to the details. You forgot the negative sign. Well, that's paying attention to the details. All right? Now, for the Y bars. This one, you really have to make sure you got these correct, because this is going to affect everything. So from the x-axis up to the center is how much? Well, it's half of 6. That's 3. For the triangle, you're going to go up this way. That is h over 3. That's 6 over 3. That's 2. And this is where you got to be careful. From here up to here, well, this distance is 4r over 3 pi, which I know is 1.273. I got to subtract this number from my 6 to give me 4.727. It is very common for students to go, oh, 4/3 by 1.273, and they just put 1.273. No, it's from the x-axis up to the central. So what you're getting is only 1.273 from the straight edge. I now have to subtract that from 6 to get all the way down to the base. So be careful. Now I've just got to multiply these two columns. And notice the way I put my 2 fingers, because I don't want to be stupid and go this times this or this times that. No, it's area times y bar. And now I got to use my other hand to do the calculation. That's 162 minus 33.4104 and 101.587. Sum this column, I'm going to get 101.589. 101.589, that's going to give me 3.038. So my centroid lies at 3.971, comma 3.038. That's 5 points on the test. Yeah. Pardon me? Oh, I gave you the wrong number. Sorry. That's my pen's gone. That's supposed to be minus 27. My bad. The whole thing down here is 101 point. That's wrong. It's minus 27. The answer is still correct, 3.038. Yep. What's this say? What's this say? Do you think I pulled 4/3 out of my ass? Take that. All right. Now, this, if I go to the base or the x-axis, is really an easy thing to fill up. What?
What is that central marginal error you have for each of these values?
I carry 3 decimal places.
Okay.
So like a point off?
For what? Decimal places?
No, like.
No, dude, if you can give me 3.97 and you write 72, I'm gonna piss off 0.001 on a daily basis. You give me 3.71, I'm gonna go great. You give me 3.72 or 3.9715, I don't care. And the reason I don't care is I'm gonna go straight down these numbers and I'm gonna go check. If all of these are checked off by me, then if you round here, okay. I ain't that picky, sneaky, whatever. All right. So this is a rectangle, quarter circle, and triangle. Again, remember, these are negatives because they're cutouts. So individual pieces have to be negatives. What am I going to do here? I'm going to add, I'm going to put in the areas. 54 minus 7.068 minus 13.5. If I'm going to go to the base, my DIs have got to be the Y bars. Well, that's easy enough. 3, 4.727, and 2. Well, that's 4, that's 9. Whip up your calculator, square that number. 22.344. Multiply these two numbers together to get this. 486. Multiply these two numbers together, get minus 33.410. Multiply these two numbers together, looked at the wrong value, minus 157.931. multiply these minus 54. Add this column, 274.069. Please notice how quickly you can get, I mean, you got 80% of the table completed, and you really didn't think much. You didn't do a whole lot other than copy 2 columns, square, and multiply 2 columns. That was it. I could teach a freaking 8th grader to do that. Or even a 5th grader to do that. All right. Now this is where this baby comes in. So if I'm going through the CG, that would be this formula, BH cubed over 12. If I'm taking the I about the base of the rectangle, then I would be using BH cubed over 3. So it depends on what you're doing. Since I've taken everything about the ICG, I'm going to use the formulas 112 B 9 times 6 quantity cubed 162. Quarter circle, that's 0.05488 R 3 raised to the 4th. That's a minus 4.445. Notice I'm trying to keep 3 decimals. 136B, in this case, 4.5 times 6 quantity cubed, that is minus 27. Add this column, 130.445. Add these 2 columns together, I'll have I about the base, or I about the x-axis, is equal to 404.624. If I want the ICG that goes through the x-axis, that's going to be I base 404.624 minus A 33.432 times the distance. What's the distance from the x-axis to the centroid? Y bar. 3.038. So ICG XX is going to equal to 96.065. Inches to the 4th, meters to the 4th, feet to the 4th, centimeters to the 4th. It's all to the 4th power. Yeah? Got it? So this is the eye that goes through the face. This is the eye that goes to the overall centroid of the figure. If I asked you, hey, tell me the radius of gyration about the x-axis, well, that would be k-axis equal to the square root of 404.624 divided by the total area . And you take the square root of that. If I told you find me the radius of gyration about the centroidal x-axis, well, I'm going to put 96.065 here divided by 33.432, which is the area of the shape, and then take the square root. Easy, nothing fancy. Any questions on that? That's going to be the first problem on the test. Of course, you'll have some other figure. Yeah.
For the water circle, I why is that instead of three, so like height, the height is like if you add 3 to be 1.7, it's different as what you did. Like,
Why would I add 3?
It's like
I'm going from the x-axis to the centroid. I don't understand why you're adding 3. So here's the x-axis. The centroid of this quarter circle sits right here. That's 3. And then there's an additional 3. The centroid lies here. From the straight edges, it is 4r over 3 pi. That's the 1.273. I want to go from here to there. What the hell is this distance, h? Or d? Well, this whole thing is 6, and that is 1.273. 6 minus this, gotta give me that. Okay. I'll leave this here. If somebody wants to make a copy or take a picture, you're more than welcome. And this is the problem originally. If you want to take a picture of it. All right, next problem is going to be, of course, a shear bending. Shear bending. Somebody sent me a chat on Teams. Hey, are you giving us the support reaction? Did you really have to ask me that question? Seriously? What the fuck are these?
I don't know, I can't see.
And every test question you have in the testing manual, that's there. Why would you ask me that question? Kind of a silly question, don't you think? Hey, are you giving us the support reaction? No, I want you to start out messed up so you can mess up both diagrams immediately. I'm not testing your ability to do equilibrium. I'm testing your ability to do shear bending moment diagrams. I used to not give those. Everybody fucked up A, Y, B, Y, and therefore every single diagram was screwed up. So now I give you A, Y, B, Y, and then you can screw up the diagrams from there. Right? So, I see a P1. P1 is 100. Guess what we're starting at? Minus 100. There's no load. Constant across. Next, I see an AY. AY is 387.5. Positive because it's upward. I have a minus 100. But I also have a P3, which is upward, 700. Wow. Add 3 numbers together. Oof, hard. Terrible. That gives me a value of 987.50. So I'm going to shoot up to 987.50. There is no load. Horizontal across. Next, I see a triangular. What does this mean for the shear? Linear. You don't know if it's linear to a positive, 0, or down to a negative. The only way to find out is to actually find the area underneath the load curve. Well, the area here is 6 times W1. W1 is 500. That's a negative 3,000. That's a downward load, negative 3,000. Okay, negative 3,000. Added to the 987 is going to give me minus 2012.5. So I'm going to go down here to 2012.5. And I'm going to go there linearly. So bring your rulers with you so you can draw me a line. Then BY kicks in. BY is positive 2612.5. Add that up. 600. So we're going to jump to a a value of 600. There is no load, so it's constant across. This better be what? 600, is it? 600 it is. I'm going down to 0. Now, you have most of it done. What else do I need? I need you to find me this x. How do I find this x? Well, what's 987.5 divided by W1, which is 500? That gives me 1.975. Now, on the test, are you listening? On the test, I need you to keep 4 decimals. So when you find this number, if there's a 2, keep it. If there's a 3, keep it. And the reason I'm saying that is if you keep 4 decimals when you find that, you will go to 0. If you only keep like 3 decimals, you'll have a little left over. So if you want it to really go to 0, keep 4 decimals when you find that value. And I'll say that again tomorrow so that you can hear it again. But here, I'm just going to say 1.975 here, which if I add 4 to it gives me 5.975 or 5.98. Okay? Everybody knows how to do that. Everybody knows how to do it, because I'm going to take off points if you don't give me that value. Why is that important? That's important because the shear went to 0. That means I have a possible max down in the bending moment. So why did I do this? I did this because I know in the next class shear stress is equal to BQ over IT. That has to have the largest possible value. Well, that looks like 2012.5. And by the way, where is that 2012.5? Underneath the support reaction. That's why when there's failures, you say, don't touch the support reactions. I want to see them as they lay on the rubble. Because more than likely, that's probably where the failure occurred. If it's not, then it's under some large load. Well, what's the next possible load? Well, that's the largest, that's the second largest. Again, where is it at? Underneath a support reaction. Where's the next largest? 600. All right, let's do the bending moment. There is a moment. It is counterclockwise M1, which is 300. So we're going to start down here at negative 300. If it was clockwise, I'd start up here at positive 300. Then I have an area here. That is 200 negative 2, the base, times the height of 100 is negative 200. That's going to say, hey, go down to 500 linearly. Because it's a horizontal line. When I integrate a horizontal line, I'm going to get a linear line. Right? Then what happens? Well, I've got this sucker right here. That's a positive 987.5 times 2. So this is 2 times 987.5. That's going to be 1975. Well, 1975 positive, because it's a positive area, minus the 500, that's going to take me to 1475. And how am I getting to 1475? It's a positive. So up here, I'm at 1475, but how do I get there? What path do I take? Linear. So I'm going to bring my ruler and make sure I go bang. Yes? Now what happens? Oh, I see a linear line. That's gonna be 1/2 times 1.975 times 987.5. That area gives me 975.156. Well, that's a positive area plus this. Now remember, it went to 0 here. So I'm going to go parabolically to a value of 2450.16. That is 1475 plus 975.16, 2450.16. You can almost keep a tally as you go, like I'm doing. Next, what happens? Well, I have this area, negative area. That is 1/2 times the base, 4.025 times 2012.5. That's going to give me a minus 4050.16. So now, that's a positive. I'm going to add to it a negative 4050.16. That's going to take me down to a minus 1600. How am I going to get there? I'm going to get there via a parabola. So now I come in here and I'm going to draw a parabola in here that goes like so. Next, what do I see? I see a positive area, 600 times 2, 1200 is that area, 1200 positive plus a negative 1600. That's going to take me to 400. So I got to go up here to 400. How am I going to get there? Linearly. And there's a moment. That moment better be what? Is it? Yes, that moment is 400. So I get to 0. Now the big question is, what the hell is this value from here to here? And what's this value to there? So let's call it x1 and x2. I need those values. x1 and x2. Well, let's find x2 first. That's the easy one. Because I'm going to say, hey, moments equal to minus a times x minus h quantity squared plus k. This a is going to be the W1, which we said was 500. That's minus 250. Remember, a is W1 divided by 2. Times x minus, where'd this cross? It crossed at 5.975. 5.98, let's call it, quantity squared, plus k. K is 2450.16 equals 0. Dot, dot, dot. Solve this, you'll find x1, or the first x is 2.849, the other x is 9.11. So this is 9.11. So if this parabola was continued, remember it ends here, it started here, but if I continued it, it would cross at 2.849 if it was continued. But I didn't continue it because it stops there. Now this one right here, I need the equation of this line. What's the slope of this line? What's the slope of the line? I don't need that. I just look over here. This is the V, which is 987. What do I know? I know dm dx is equal to V. Slope of my bending moment is equal to the shear. Well, the shear is 987.50. There, I don't need to go y2 minus y1 over x2 minus. I already know what the m is. It's the shear value. 987. 0.50, right? I know my equation of the line should be y equals mx plus b. That m is that right there, right? If I pick two values, let's say the 500 is at x equals 2, so 500 negative. This is 987.50 times 2 plus b, solve for b. And then set it equal to 0. Or you could do it the long-ass way. Here's the long-ass way, just so you can see it. I can say dm dx equals shear, which is equal to 987.50. Separate variables, dm is equal to 987.50 dx, integrate. M is equal to 987.50 times x plus some value c, a constant of integration. You can already see y equals mx plus b being formed. At x equals 2. Why 2? Well, that's the start of the equation, that's the start of the line. It started at 2. What's the value? Minus 500. So at x equals 2, m equals minus 500. Plug that into there, plug that into there. You'll find that c is equal to minus 2475. So m is equal to 987.50 x minus 2475. Set that equal to 0. X is equal to 2475 divided by 987.5. That value comes out to 2.506, roughly 2.51. That's the long-ass way to do it. That's the integration approach. Nobody can say, you did this, that's not correct. That is correct. But it's the long way to do it, I can tell you that. So, I need you to give me the 2.51 and the 9.11 if you want 10 out of 10. If you don't give me those, I'm going to take off probably 0.3 to 0.4 from the test. So if you don't give me the x's for the shear and the x's, you're going to lose almost a point. So you get a 9 out of 10 instead of a 10 out of 10. That's up to you. You don't want to find them? That's fine. I'll take off a point. No big deal. That's usually what I take off when I don't see x's, either in the shear or in the bending moment. And if I'm not mistaken, I do believe the one that you have does cross the x-axis. So you're going to have to find me those if you want 10 out of 10. Okay? Any questions on the shear? This is important. I showed you my former student that was in the field doing a hospital, which actually he drew all 4 diagrams: the shear, the bending moment, the rotation, and the deflection diagrams. And yes, he used a software to do it, but he also checked that software. He didn't just take it blindly. So yes, you'll have software, but don't just blindly accept the values of the software. Double check them. Because sometimes you miss a negative, or you put 2.52 and you put in instead 2.25. Well, that's going to throw everything off. And you want to check, especially if you have an intern or whatever putting in this shit into your software. I don't trust interns. Just saying. How many potential civils in here? Okay, cool. One of our professors is looking for an intern for the summer. And you'll be working here. You won't be going someplace to do it. You'll be working here. Also, if you're a civil, you might not be on civil canvas, but there is also if you're going into transportation, there is the FDOT program, but they're looking to bring in, you guys are probably too young for that stuff. They're probably looking for older people for the FDOT job. So, I don't know that you'd be ready for that. But maybe, the internship here over the summer might be okay. I don't know. She did not tell me what she wanted as a knowledge base. She just said, I need an intern. So if you're interested in that, let me know. I'll put your name down and pass it on to her so she can choose whoever she wants. Any questions? Did she leave? Interview for engineering job or just cash register at Publix? Honors college, okay. All right, last problem. Last problem. Model, instantly tell me. Yeah. So could this be a type 3? Not a chance in hell. Then not going to be a type 3. Could it be a type 1 or type 2? Yeah. I won't know until I read the question whether it's a type 1 or type 2. Okay, let's read the question and see what happens. So, let me put this over here. So, the weight of block A is 240. So what I would do is I'd put the 240 right in there. Weight of block B is 170. Determine the maximum force P, sitting right here, that can be applied, keywords, without causing either block to move. What type is it? Type 2. That automatically tells me F equals U static times N. This automatically tells me some force in the X equals 0, some force in the Y equals 0. Notice, and you don't have to write the equations, but they should be in your head as you look and say, particle. I got 2 equations to play with. Once you know it's type 2, I got another equation to play with, U static times N. And then you read on, and it says the coefficient of static friction between block A and B, that's here, 0.45. And between B and the horizontal surface, B and the horizontal surface, that's this guy, 0.3. And between the rope and the drum, U equals 0.12. So I'm going to add T2 equals T1e to the mu beta for this problem. You can see physically all the equations I'm about to use on this problem. There's no guesswork. You're not guessing, should I use? No. You know exactly what you're going to do. Yeah? So, I'm going to come in and I'm going to draw a free body diagram, A, and I'm going to draw a free body diagram, B. A. Here is A. I got some cable tension. I'm just going to call it T for now. I got a weight downward 240. I got a normal force, NA. I got a friction force, FF. Over here, I should have a weight of 170. I should have a normal force, NB. I should have some sort of friction force between B and the horizontal surface. And here's the QT one. Because of Newton's third law, there's NA and there's FA. Here is Newton's third in action. Newton's third law in action. Oh, you can barely see it, right? Okay. Newton's third. Here it is NA, here it is FA. That's FA and NA there. So, two equations per free body diagram. Some forces in the y equals 0. And I usually start with the y because it usually gives me the normal force. Usually. And it does here. NA minus 240 equals 0. NA equals 240. Some forces in the x equals 0, positive to the right. That says FA minus T equals 0, or T is equal to FA. Let's write the equations here. Some forces in the y equals 0, positive upward. NB minus 170 minus NA equals 0. But NA is 240. So NB really is 410. Upwards. Some forces in the x equals 0, positive to the right. That says FB minus FA equals 0, so FA equals FB. But FA from here is equal to T, because FA is equal to T. Now, you have two possibilities. Case A, case B. A slips, quote unquote, ending slip is what I should say, and B doesn't. Well, that would mean that FA is equal to mu 0.45 times 240, which is 108. Well, based on this, T is equal to 108 for slip of A. But over here, case B, A and B slip, which means FB is equal to mu static times NB, which is 0.3 times 410. FB is equal to 123. But from here, FB equals FA, which equals T. T is equal to, for slip of that condition, 123. So what's controlling is this, because it's the lower of the two numbers. So now I come in and I say T2 is equal to T1 e to the mu beta. Well, that's going to be 108 is equal to e to the mu 0.12 times beta. Beta is pi over 2. So T2 is equal to P, which equals 130.4 pounds. And when I gave this problem, the first time I gave it out, people forgot to write down, hey, the case of A and B slipping together. And yes, if they only did this, they got the right value, but they didn't do this to check, I still took all points. Because you don't know for a fact whether A or B is slipping. You have to check. It could be that B turns out to be, instead of 123, 100, in which case that would control because it's less than 108. So you really have to check both scenarios to make sure that you've got the right one that's slipping or tipping if this was a 3D, I mean not a 3D, but a rigid body problem. You can't just say, okay, I did it for slip. Well, what if it tips? In this case, there was no tipping because the both are particles, but there is a possibility that B could slip. In this case, it wasn't. A was the one that was slipping. All right, any questions? Say that again. Yup, yeah. Yeah. Wait a second, I can't hear it. Why is everybody in a hurry? I got you still for at least 5 minutes. What? There's no tipping because there's no dimensions. If I don't have a D, I can't have an M. If I don't have an M, I can't tip. Right? Any other questions? Yeah. Whatever you're most comfortable with. They're all easy. I don't see them as being hard. Yeah.
Can you zoom out, please?
Huh?
Can you zoom out, please?
Zoom out of this. Want me to zoom out like this? Is that what you want?
How do you think like the orange is solving better?
He just asked me that question, so you're all the same to me. I don't know. I wouldn't say there's anything that stands out as easy or hard or whatever. They're all about the same. Whatever you do, you pick the one you want to start with. You know, usually the shear bending over axis is pretty quick to do. So bring a ruler with you. Oh, and bring a stapler if you have one, because the first thing you're going to do is you're going to take out the last 2 pages, which is the chart and the formula sheet. And then we're going to attach the chart at the end when we turn it in to the back page of the test. Is it required to bring a ruler? It would be helpful. I wasn't angry. I think if you could do anything that we did in class, I think you'll be fine. I mean, probably the test questions that I gave, like there's what, 7 test questions?
Yeah.
The last 3 are probably harder than what's on the test. Yeah.
For the shear bending, can you show kind of area under a quadratic in the shear?
Under a what?
Like say if there's a parabola in the shear.
Oh, the next parabola.
Next parabola.
1/3 AB. That's what you want. Should be on the sheet. And you're getting the sheet, yes. I've said that 1,000 times already. Want me to hold your hand while I say it? Sheesh. Any other questions? Yeah. They're going in eventually. Relax. Other questions? Sure? Yeah. Hey, I want you to know that I enjoyed having you here. Hopefully you learned a lot. If I offended anybody, it wasn't intentional. I like to make fun of myself and you. So if you're going to be a snowflake about it, you probably were somewhere along the line offended. That's not my goal. I try to keep this as entertaining as possible. So if you got picked on, it was to keep everything funny, not necessarily because I hate your guts. And if you got a nickname for me, then I like it. If you didn't get one, I didn't get to know you enough to give you anything. Like people sit way in the back, I can't give you anything. I'm like, who the hell are you back there? But she tried to sneak in, he tried to sneak in. I know my students. Don't be sneaking in. Huh? Also, they're going to send you out a survey. If you want to fill that out, great. If you don't, I don't give a shit. Most of the time, people don't fill it out, and so you get really either people that really, really like you or people that really, really hate you. And so it's not really like I'll have, about 250 students in statics, and I'll get 23 responses. Well, 23 out of 250, that's not exactly a huge sample. So, any other questions? I'll see you tomorrow at 8 o'clock.